Solving systems of equations by the substitution method. This is the only topic we are covering in this lesson. So let's get right into it. In the last lesson, we actually graphed these two equations. Y equals 3x minus 1 and y equals negative 2x plus 4. In this lesson, we're going to solve the system of equations by a different method, not by graphing, but by substitution. And the first thing we want to notice is that y equals an expression and y equals an expression. So since both of these expressions are equal to y, we can set the two expressions equal to each other. Once we do that, we can then solve for x by adding 2x to both sides of our equation, adding 1 to both sides of our equation, and then dividing both sides by 5. And then x would equal 1. Next, in order to figure out the y-coordinate, we take the value for x, which is 1, and plug it back into either one of these two equations. We can make this x 1 or this x 1 and figure out what our y is equal to. So y equals 3 times 1 minus 1 will give us y is equal to 2. So the solution to the system of equation is 1, 2. Let's try a different one. In this case, both equations are not equal to y. But I do know that x plus 3 is equal to y, so I can substitute x plus 3 in for y into the other equation. When I do that, my new equation looks like this. And then our goal is to solve for x. First, distributing 3 to x and 3 to 3. Combining like terms, 2x plus 3x. Subtracting 9 from both sides. (5x) equals 5. So again, in this case, x would equal 1. But remember, we're looking for a solution. And a solution requires an x coordinate and a y coordinate. So we take the value for x and plug it back in to one of our equations. This top equation is the easier of the two equations to plug it into. So when I do that, y equals 1 plus 3. So y equals 4. So the solution to the linear system of equations would be the point 1, 4. Looking at yet another one. This problem looks very similar to the last system of equations problem that we did. So take a moment and try to figure out what the solution is. You can pause the video if you need to. Okay, the first thing we want to do is take the value for y, which is negative 2x plus 4, and plug it in for this y. Our new equation would be this. Next thing, we want to distribute our 3 to negative 2x and to 4. When we do that, we end up with this. Combining like terms, we end up with a situation where we eliminate our x's. This means that we do not have one solution. We will either have infinite solutions or no solutions. When you end up with something that is true, 12 equals 12, or 0 equals 0, or 5 equals 5, what this is saying is there will be a solution to these two equations only when 12 is 12. Well, 12 is always 12. So what that means is every point in common will be a solution. So that means you have a dependent system. Please notice 12 equals 12. This is something that is true. I have eliminated my x's, and this is true. Dependent system. This question is very similar to the one we just did. Please pause the video and try to work this problem out. Okay, the first thing we want to do, we want to substitute the value for y in for the y in the other equation. When doing that, we end up with this equation. Next, distributing R2 to 3x and to R2, we would end up with this equation. When we combine like terms, negative 6x and 6x will be eliminated, and we are left with negative 4 equals 12. In this situation, we have also eliminated our x's. But in this problem, negative 4 does not equal 12. So this is not a dependent system. What this means is we have an inconsistent system. So when you eliminate your x's and you end up with something that is not true, you have an inconsistent system. What that means is these two lines will be parallel. Let's try one more. Now in this problem, we are not solved for x, nor are we solved for y. So the first thing we want to do is either solve for x or solve for y in one of these equations. Now, in these three problems, please take time to work these problems out. Looking at them, they look all very similar. One of these problems will give you a consistent system. One will give you an inconsistent system, and one will give you a dependent system. Please take the time to work these problems out and identify which one is consistent, which one is dependent, and which one is inconsistent. Pause the video, please. Now, on to some word problems. A local market is making 75 pounds of his house nut blend by mixing two types of nuts. The first type of nut is walnuts, and they cost $3 per pound in the show. The second type is almonds, and they cost $3.50 per pound in the show. The blend is priced at $3.30 per pound. Find how many pounds of each type of nut the market should use in the nut blend. In this problem, we need to first identify what the two system of equations are. The first comes from, you have a total of 75 pounds. So since we don't know the number of pounds of each nut, then we would have one variable represent almonds and the other variable represent walnuts. Next, let's look at the price for the walnuts and the price for the almonds and the price for the total. So the price for the walnuts, the price for the almonds, and the price for the total. We're going to take these dollar amounts and multiply them by each one of these terms to get us our second equation. Now you have a system of equations. Please take a moment and try to solve the system of equations. Pause the video, please. Your homework is lesson 4.2 in My Math Lab. Read over the workbook slides for the next lesson, 4.3. Remember to submit your notes by Sunday, 11:59 p.m. And don't forget to take the weekly quiz over lesson 4.1 and 4.2. Thank you.